Hello everyone. Welcome to the series on Advanced Database Management Systems. My name is Dr. Neeti Mathur and I'm your online faculty for the subject. So far we have talked about query processing. We also discussed converting SQL queries into relational algebra. In this particular session, we are going to talk about the basic algorithms while working on the relational algebra. So let's get started. By the end of this session, you will be able to elaborate upon the basic algorithms for executing the query operations. Before we get into the depth of the topic, let us understand what exactly is query execution. So, query execution is a very important task that the research analyst or the data scientist they work upon. Basically, using SQL, they extract the exact data which they require for their research purpose. So here, basically, through query execution, the data scientists are retrieving the data and they are manipulating the database management system in order to extract the information that they are looking for. So basically, query execution is helpful in efficiently processing the user query. Now let us talk about the relational algebra once again. So basically, as we learnt about it in the previous session, this is the foundation for query execution. And it is a set of operations on relations. So there are different operations such as joins, union, that are performed, and through that you can manipulate the data. So these operations in relational algebra are selection, projection, join, and union. Now let us talk about the selection operation first. So basically, it helps in filtering the tuples based on condition. So you put your condition in the query and then the specific tuple is filtered and you get the exact result that you are looking for. Now there are different types of selection. One is scan-based selection and then there is index-based selection. So for scan-based selection, you basically scan the tuple and then filter the data. In index-based selection, you have these indexes that help you in selecting the required cell or column or row so that your operation is performed very quickly. Then comes the projection operation of relation algebra. So here, basically, it is used for extracting specified attributes from the table. There are simple projection, which are simple in nature, and then there are qualified projections wherein more filters are applied. Then comes join. So under this operation of relational algebra, basically it combines the tuples from multiple relations. So it could be different tables, different columns, etc. Then comes nested loops join. So basically it goes from inner to outer layer and then it is basically the operation is performed so that quickly you can execute the query and get the result. Then comes the hash join. Then comes the merge join. So as the name suggests here, you are using the merging function for joining the tables or columns. And when it comes to hash join, there are hashes just like tags are associated and quickly you can retrieve the information. Then comes union. So it basically combines the multiple relations in the table. So you can use set union where there is a set of table as you can see in the image. Then it also helps in removing or eliminating the duplication. So if there is duplicated data, it can help in getting rid of it. Then comes the query graph. Now, query graph we are going to discuss in detail in the upcoming sessions, but it represents a query as a graph. So as you can see here in the image, basically this is a graph. It is nothing but a query. So here are the nodes, which are relations or constants. And there are edges, which are operations, the relational algebra operation. This is the query tree. Again, we are going to discuss about query tree in detail in the upcoming sessions. So as you already know that SQL query is structured as a tree so that it can be executed quickly and easily. So it represents the query as a tree, and the leaves here are the relations or constants, and the internal nodes are the operations. So as you can see in the image, the natural join manager underscore SSN or equals to SSN is the operation, whereas the leaves are the constants such as employees, department, and so on. Then comes query optimization. You already know that the primary task of query optimization is to help in quickly resolving the query and quickly giving the output for that query. So basically it is used for improving the query performance, and it is used for choosing efficient algorithms, and it also helps in reordering operations. So as you can see in this diagram here, this is basically a flow where you can see that query in high level language is presented to the system, and then there is parser and translator. As you know that this is the primary step, and then comes your query optimizer. So here DBMS catalog is referred to, and internal representation of query is done. Then comes the execution of plan, followed by query execution engine, which works on the data, and then ultimately you get the result for the query. Then comes the indexes. So as you already know that through indexes, you can extract the query and you can get the result quickly because you have the reference of indexes. Now let us talk about external sorting. So basically it is used for sorting large databases, because when we talk about big business houses or any kind of business, they have these large databases because they keep on collecting the data. So external sorting is used for sorting these large databases. Then the sorting phase, it basically includes merging small sorted runs which already are sorted and are small in size. Then comes the merging phase. So here you keep it simple by merging the sorted run. Then comes hashing. Again, it is efficient way of data retrieval. And then the hash function includes mapping of the keys to indices. It also protects the collision by handling multiple keys. Then comes indexing. So basically it is used for accessing the data efficiently and quickly. The index structure is in such a manner that the data is organized for fast search. Thus, it helps in data optimization. The index maintenance is also important because as and when the data is stored, it needs to be updated. So updating of index on data changes is important task which must be performed on regular basis. Then comes the physical storage. So basically, it means organizing the data on a disk for storage purpose. So the file is organized in a sequential and indexed manner, whereas the page is organized in fixed size blocks manner. Then comes the query evaluation. So here the query is transformed into execution steps. So as we already talked in our first session, that this execution could be cost based or execution plan based. So when it comes to cost based optimization, uh, The optimal plan based upon low cost is selected, and when it comes to execution plan, the sequence of operations is considered. So with this, we have come to an end of this session. In this session, we have talked about the basic algorithms for executing query operations. I hope you are clear about this session and you have understood the concepts. I'll see you soon. Thank you.